Okay, so there's a property called the comparison property of inequality. And it just says that if A is equal to B plus C and C is not 0, then A is got to be bigger than B. It's something that's really obvious, especially when you put numbers in here. So for example, 5 is equal to 2 plus 3, right? And so if I just wanted to compare 5 to 2, well, 5's got to be bigger than 2, right? That's what that's saying. If 5 is equal to 2 plus 3, then 5's got to be bigger than 2. Okay, we're going to use that kind of reasoning with triangles. And the first thing we're going to bring up is the triangle exterior angle theorem. If this angle right in here were 40 degrees, what would angle 1 be? 140 degrees, right? Why? Well, these two angles make a what? A linear pair. And we know that two angles that make a linear pair are supplementary, add up to 180. And so if one's 40, then the other one's got to be 140. How about this? We don't know what angle 2 and angle 3 are, but if we were to add them up, what would we have to get? 140 again. Why? Because all three interior angles of a triangle add up to 180 degrees. So what could we say about angle 1 and angle 2 and angle 3? All of them are equal? So the measure of angle 1 is equal to the measure of angle 2 plus the measure of angle 3. That's called the exterior angle theorem, and you may remember that from prior class. Okay. So if the measure of angle 1 is equal to the measure of angle 2 plus the measure of angle 3, and all these angles are greater than 0, what could we say about the measure of angle 1 if we compared it to the measure of angle 2? It's got to be bigger. And that's what this corollary is saying. Or if we took the measure of angle 1 and compared it to the measure of angle 3, which one's bigger? Angle 1. Okay. So let's apply that to example 1 here. Take a look at the figure we have here. And the question is, why is the measure of angle 5 greater than the measure of angle C? You can see why that's true. Okay, can anybody see why measure of angle 5 is greater than measure of angle C? Okay. Okay, let's focus in on the triangle I'm highlighting here. And let's use the exterior angle theorem. The exterior angle theorem says, well, angle 5 is an exterior angle, right? So the measure of angle 5 is going to equal what? Angle 1 is not part of that triangle I highlighted. Just look at the triangle I highlighted. So the measure of angle, which one? C, plus the measure of angle 3 or A, doesn't matter, right? I'll just put A, but same thing. So that's what the exterior angle theorem says. So if that's true, and we just want to compare the measure of angle 5 with the measure of angle C, which one's got to be bigger? Measure of angle 5. And so, so the reason behind this is, well, we start with the exterior angle theorem. We get this equality, and we know that the measure of angle A has got to be bigger than 0. So the measure of angle 5 has got to be bigger than the measure of angle C. Okay. Look at the next theorem. Theorem 33. It says that if two sides of a triangle are not congruent, then the larger angle lies opposite the longer side. Okay. Another important thing I want you guys to understand. Let's say that XZ is the longest side of this triangle. What this theorem is saying is that if you look at the angle across from that longest side, which would be angle Y, that would have to be the largest angle. Okay. It also works with the smallest. So like, let's say that XY is the smallest side. Which angle do you think would be the smallest angle? Yep, angle Z, because angle Z is across from the smallest side, so this would be your smallest angle. So let's apply that to the second example. You have three side lengths to this triangle, 2.7, 4.3, and 5.8. List the angles in order from smallest to largest. So which angle would be the smallest in this picture? Angle M, because angle M is across from the smallest side, right? Which angle would be the largest? K, because angle K is across from the largest side. And then that leaves angle L to be in between the smallest and the largest. The next theorem pretty much says the same thing, but in the reverse order. So it's kind of the converse of the last part. So if two angles of a triangle are not congruent, then the longer side lies opposite the larger angle. So if we say like, okay, angle A is the largest angle, which side would be the largest side? So you go across from that angle, we get the largest side here. And we kind of have, we've been working with this before. Like if we have like a right triangle, which angle is the largest angle? The 90 degrees, right? And if which side do we always say is the largest side? The hypotenuse, which is across from the largest angle, right? If we work with, remember when we were talking about isosceles triangles, where we have the same side length. Well, if we looked at the angles across from those side lengths, what would we learn about those? They're also the same, right? And so we've been working kind of with these ideas, but it applies to every triangle and every angle on every side. Okay. So in example 3, in the figure below, measure of angle S is 24 degrees. Measure of angle O is 130 degrees. What would measure of angle X be? What do we get? 26 degrees. Okay. So which side of this triangle is the shortest side? OX, because the smallest angle is 24 degrees, and across from that would be OX. So OX is the smallest side. Explain your reasoning. So what would we say? So OX because it is across from the smallest angle. There's one more theorem I want to look at with you guys, the Triangle Inequality theorem. If I have 3 segments, so say one segment is length 2, one segment is length 3, and one segment's really long, say like length 10. Could you put those 3 segments together to make a triangle? No, you try it out and maybe you put the length 2 here and you put the length 3 here and they just can't reach each other. So there's a problem, right? So not all triangles are made up of any three segments. There has to be some relationship between those three segments to make the triangle work. And the relationship is stated right here. The sum of the lengths of any two sides of a triangle has got to be greater than the length of the third side in every case. Practically speaking, what we're going to do to check this is we're going to find the two smaller sides, because those are the ones that really matter. So the sum of the lengths of the two smaller sides always has to be greater than the length of the third side. Well, if we use the two smaller sides, that would be the largest side. Okay, so that's going to be our test. If I give you three side lengths, you're going to take the two smaller sides, add them up, and make sure that sum is greater than the largest side. So in my example here, if I added 2 and 3, I'd get 5. That's not bigger than 10, so it's not going to work. What if I gave you like a side length of 2, side length of 3, and a side length of 5? Could you make a triangle out of that? Getting closer. So what's going to happen here is, you know, as you fold it in on itself, they're going to actually, to make them meet, they're going to actually, you know, you have your 2 and your 3 here, and it'll kind of fold in on itself. It won't look like a triangle, it'll be a line segment. It will be connected, but it's kind of a degenerate triangle, so it's still not going to give you that shape. So 2 plus 3 equals 5. It's not greater than 5, and we need it to be greater than 5 for it to look like a triangle. Okay. So how about here? We have side lengths 2, 6, and 9. Can we make a triangle out of that? No. Why not? If we add 2 plus 6, the two smaller sides, 2 plus 6 is not greater than 9. And that's what we need. Part B, I'm going to change on you. Okay. To root 32, root 72, and root 162. And I want you to decide if you had those three side lengths, could you get a triangle? What are we thinking? Make a triangle or not? Square root of 32, square root of 72, square root of 162. Can you locate the two smaller sides? Right? The square root of 32 and the square root of 72 are definitely going to be smaller sides. If you add those up, is it going to be more than square root of 162 or less? Less? Why? Now, how do you add those up? What is the square root of 32 plus the square root of 72? Can you add the 32 and the 72? No, not yet. You have to adjust them. Can you rewrite square root of 32 as something else? What? 4 root 2, and this is, okay. So when we add those up, we get 10 root 2, right? How about 162? Can you change that to what? 9 root 2. Okay, so now we can compare 4 root 2, 6 root 2, and 9 root 2 easier, right? So if we change the way they look. So will this make a triangle? Yes. Because 4 root 2 plus 6 root 2 is greater than 9 root 2. Okay. Example 5. The lengths of two sides of a triangle are given. Find the range of possible lengths for the third side. So if we know two side lengths, 18 and 23 on part A, we don't know the third side. That third side could be the largest side, but it could also be the smallest side, right? What values could that third side be? What's the, and you're going to give me an upper bound and a lower bound. You're going to say, well, it's got to be in between these two numbers. Can't be bigger than this number, but it can't be smaller than that number. So let's think about the upper bound. X has got to be smaller than what? If X, let's get X as big as we can get it. Okay, so let's say X is the largest of the three sides. It can't go above what? It can't even be equal to it. Can't be above or equal to 18 plus 23, which is 41. Right? Because the rule is, if I pick 42 for X, it wouldn't work because I have to add my two smaller values, and that sum has to be bigger than my third value. So X has to be less than 41. Can X be anything less than 41? Can X be 0? Can X be 1? So it can't get too small. It has to be, let's now go on the smaller side. What's this? X has to be bigger than what? Has to be bigger than 5. How'd you get to 5? 23 minus 18. Because if X were 5, what would happen? You go 5 plus 18, and that equals 23, and that wouldn't work. So we need X to be bigger than 5, but it has to be smaller than 41. So anything in between 5 and 41 would work for us. Okay, so do the same thing for part B. Find out what that third side, we'll call that side X again, has to be between. What's the range? What's the largest it can be? It's got to be less than 55, which came from 20 plus 35. And it's got to be bigger than 15, which came from 35 minus 20. Good. No, but I'm just doing it so you see where it came from. Okay. All right. Look at this diagram. Think about what we've learned so far in today's lesson with the angles and side lengths and stuff, and decide which segment in this diagram is the smallest segment. Now, this may not be drawn to scale, so don't pick the side that looks the smallest. But based on the angle measurements and some of the markings in the diagram, try to pick which segment would have to be the smallest segment in the diagram. All right, everybody have their pick? Okay, what is it? QR. Everybody agree? No? What do you think? RS. Any other sides that we're worrying about? And I know why these two were picked. QR is across from the 30 degrees, right? Which is the smallest angle in the whole diagram. And I know why RS was picked too, because that's across from the smallest angle in the triangle on the right. Okay, so you have the side QR is across from the smallest angle on the left, and this is the smallest angle from this one, right? So sometimes it can get a little confusing, and there's different ways to think through this. I'm just one way to think through this is just to come up with some fictitious values, okay? I'm gonna make up some numbers here. Let's say this side length is 10, okay? And let's just look at this triangle, okay? In the triangle I highlighted, which side has to be the smallest side? You guys, everybody agree that QR has to be the smallest side? Why does it have to be the smallest side? It's that theorem that said, hey, if you have angles that are different, right, the smaller angle has to be across from the smaller side. So I'm going to make this, I don't know, 5. Okay. I don't know if that goes, it probably doesn't go with those angles, but it has to be the smallest side. So now let's transition, because that side that we just marked is a shared side. Now let's transition to what I'm highlighting in green here, okay? So the green triangle already has a side length. It has 5 as a side length. Now if we compare QR to RS, which side has to be bigger in the green triangle? Why? Yeah, so see that? So in the green triangle, QR is across from 50, where RS is across from 40. So this has to be smaller than 5. I'll make it 4. And so RS has to be the smallest side. Does that make sense to you guys? It can get a little confusing, but if you look at one triangle at the other, you get to, okay, RS has to be the smallest side. For the homework, I've adjusted a couple things. Number 3, for example, you want to change to what I have here, 7 root 3, square root 143, and 12 for your 3 side lengths. When you do your homework, do not use a calculator. Unless that calculator is your brain. Your brain is the best calculator out there. Okay. Okay. Everybody got 3 down? There's one more change I want you to do to the homework. On this section, I want you to change 16, 17, and 18 to what I have here.